Hello everyone and welcome to Spare Course. In the previous episodes of this video series, we focused on how to explore the optimal cloud service types for your specs, such as 32 CPUs, 100 gigs of memory, and maybe even a few A100s for your data science task. Now we will look how to find those specs by running some automated resource trackers in the background, not blocking your main job, and also getting automated recommendations about the optimal server type. To do so, we are using the open source resource tracker Python package that we maintain at SpareCourse. I will post the related blog articles URL if you're interested in the details, but for the time being, I will focus on our Metaflow integration so that we can get up to speed very quickly and highlight some of the most important features. If you're not familiar with Metaflow, make sure to check that out. It's a super cool workflow orchestrator framework for data scientists. To get started, we will use the fantastic Metaflow Sandbox provided by our friends at Outer Bounds, so that we have VS Code already up and running, installed Metaflow and so on, and even some nice UI, as we will see. Also an example workflow with 3 steps already defined here, which are not doing much, just printing a few strings as part of starting, eating, and then wrapping up. I would like to do some actual computation so that we can measure what's happening in the background. So what I will do is importing some data so that we can train some actual model. So I will go with the make classification function to generate some data for the training, and also let's do a GBM. So importing the his gradient classifier, and in the start step I will create the training dataset. I will skip having a validation dataset for the time being because I want to keep this demo super lightweight. Let's have, let's say, 1 million samples with 20 columns, and we will store that in artifacts so that we have access to those in a future step. And Metaflow will also archive that if we want to check that out later. Our model will be his gradient boosting classifier, and let's store the result as an artifact as well. Here I will call this define model fit on the x and y attributes of self, and that's pretty much it. I don't think we need anything else. So we are generating some data, we're fitting a GBM on it. What's missing is figuring out how much resources we need. Do we need multiple CPUs, how much memory, and so on. To help with that, I will install the resource tracker Python package from PyPy, which provides Metaflow extension by default, and we can make use of that by using the track resources decorator that you can just add to any step, and it will start background processes for tracking. Fingers crossed now. So it seems that our job is actually starting up, which is good. In this process ID, the start step is being executed, which is generating our example dataset. Hopefully that will run pretty quickly and move on to the next step, which will do the actual training. So it took some time, but we have an example dataset created. Now the eating step is running, and while that's wrapping up, let me open up the Metaflow UI so that we can check on the resource usage as this wraps up. It seems that things just finished in less than a minute, which is great. So let's check the Metaflow UI, and yep, the start step was running for like 17 seconds. Unfortunately, we didn't do any resource tracking, so the only thing we know about this is that we printed starting. Now let's see what was happening in the eat step. We were also just writing eating, but thanks to the resource tracker, we get an interactive HTML report, which includes some information about the server where we were running this task. It has quite a bit of memory and a few vCPUs. But if we focus on the current process that we started, you can see that it was using on average around 2 CPU cores. The peak was 2.5. And also if you're looking at the memory usage, it's below half gigs of memory. Training took around 10 seconds. And if you're looking at the detailed CPU usage, which is using a sampling of 1 second by default, but you can configure it if you wish, you can see that there's a green and the blue line. The blue line is the system level resource usage, so other processes might be using some extra resources. We should focus on the green one, which is showing that at the beginning we used a single CPU, then it ramped up to using 2 CPUs. So based on this, it seems that using 2 CPUs might be the best option. No need to scale to 32 with this small set of data set. And this is automatically provided for you. So based on the average CPU usage, peak memory usage, and a few other things we take into account, there's a recommendation to use this amount of CPU and memory. And you can just grab this and add to your Metaflow job. Of course, we still have to import a decorator, but from now on, this will be the allocated resources to this job. And maybe if you want to run this scale out to the cloud, you import a Kubernetes decorator so that it can run in a pod, or you allocate it to AWS batch, and so on. Something in the works is that we will be able to auto-tune the resources for you, so you do not even have to copy-paste this recommended amounts. Stay tuned, that's coming in a few weeks, but there are a bunch of other things to note here, so please make sure to check this out if you're interested. We also recommend which might be the cheapest server to run this thing with 2 CPUs and that memory. You can click out, you get a bunch of details about the server, including a lot of benchmarks and so on. Anyway, if you have any feedback, we are super happy to hear. If you're interested in running this in standalone mode outside of Metaflow or using in another framework like Flight and so on, please reach out. We are continuously improving this and honestly super happy to prioritize features as per your request. So thank you very much and looking forward to see you in the next episode. Bye bye.